In this class, we discuss or derive the law of force and the velocity of the particle under central orbit if the orbit is parabolic. Okay. Now we first know polar equation of parabola. If the center of force is at the focus of the parabola, right? This is the initial line. This is the initial line. Let this be S, because here says that the center of force is the focus, and this is the parabola. This is the parabola, or let it be any conic. Maybe parabola, maybe ellipse, maybe hyperbola, or maybe any other. And we know that if this is focus and the positive direction of initial line is the axis of the conic, then the equation of the parabola or equation of the conic is 2a by r. This is equal to 1 minus e cos theta. Sorry, this is L, where L is the semi-latus rectum. Semi-latus rectum. E is the eccentricity. Eccentricity. And at any point P, this is the point P, and the angle of inclination or vectorial angle is theta, and this is the radius vector, this is r. So theta with a vectorial angle. And for the parabola, if the conic be parabola of latus rectum, (4a), then we must have the semi-latus rectum is 2a, and for the parabola eccentricity this is equal to 1. So the polar equation of the parabola is given by this is 2a and this is 1. Okay. And the central force act like this, that is along the PS. This is the central force F. Now in central orbit we put U. This is equal to 1 by r. So this is equal to 1 minus cos theta by 2a. And we find du d theta and d2u by d theta 2. And these are clearly, this is sin theta by 2a. Double derivative d2u by d theta 2, this is equal to cos theta by 2a. Now the differential equation of central orbit in polar form as u plus d2u by d theta 2, this is equal to f by h square u square. So we get f, this is equal to h square u square into u plus d2u by d theta 2, and this is u means 1 minus cos theta by 2a, 1 by 2a minus cos theta by 2a, and plus d2u by d theta 2 means cos theta by 2a. So we get h square u square by 2a. So capital F is h square u square by 2a, and this is h square by 2a into 1 by r square. So the law of force is F proportional to 1 by r square. Hence the force varies inversely as the square of the distance of the point from the focus. This is the r. Now the expression of velocity is given by v square. This is equal to h square into u square plus du d theta whole square, right? And this is equal to h square into u square means 1 minus cos theta by 2a whole square plus du d theta whole square. This is sin theta by 2a whole square, and we get h square into 1 minus 2 cos theta. This is by 4a square, because here 4a square and here also be 4a square. 1 minus 2 cos theta plus cos square theta plus sin square theta, and this is h square by 4a square into 1 minus 2 cos theta plus 1, and this is h square into 2 into h square into 1 minus cos theta by 4a square. This is v square, and now we put the value of u here, 1 minus cos theta. This is equal to u into 2a, so we get 2h square by 4a square into 2a into u, right? And we cancel a and 2 to 4 and 4 cancel out, so we get velocity square. This is equal to h square by a into u, that is velocity square is proportional to 1 by r, that is velocity is proportional to 1 by root r. This is the velocity and this is the law of force in the central orbit. Okay, and this velocity and law of force is also being deducted by another method, or by using pedal differential equation of central orbit. Now we start this method. We put the value of 2a by r from this relation and get as minus 1 minus cos theta by sin theta. So this is minus 2 into sin square theta by 2 by 2 into sin theta by 2 cos theta by 2. So this is minus tan theta by 2, and this is obviously tan pi. And if we take as tan pi minus theta by 2, so we get phi. This is equal to pi minus theta by 2. This is the relation between theta and phi. Now we put the value of phi from here to this relation and get p. This is equal to r sin pi minus theta by 2, that is r into sin theta by 2. Okay, and r into sin theta by 2, and we get by squaring both sides p square. This is equal to r square sin square theta by 2 and r square by 2 into 2 sin square theta by 2, and we put the value of r square by 2 into, this is 1 minus cos theta by using trigonometrical formula. Now put the value of 1 minus cos theta. This is equal to 2a by r, and get r square by 2 into 2a by r. This is ar. So the pedal equation of the parabola as p square equal to ar. Okay, this is well known result, and this is the pedal equation of parabola. Now differentiate with respect to r, we get 2p dp dr. This is equal to a, and put the value of dp dr. This is equal to a by 2p in this relation. We get capital F. This is equal to h square by pq into a by 2p. So h square a by 2 into 1 by p to the power 4. And what is p to the power 4? P to the power 4 means a square r square. So we get f. This is equal to h square a by 2 into 1 by a square into r square. So the relation F is given by h square by 2a into 1 by r square. So the log force is again we get F proportional to 1 by r square. This is the same as the polar coordinate, right? Now for the velocity we get v. This is equal to h by p. And what is the value of p? The value of p is equal to h by root under ar, that is equal to h by root a into 1 by root r. So the velocity is again v proportional to 1 by root r. So the formula of log force and the formula of velocity in two coordinates are same. Okay, this is the complete proof or complete determination of log force and velocity in two methods, in polar and in pedal. Okay, thank you for watching. We know that the pedal differential equation of central orbit is, this is F equal to h square by tq into dp dr. This is the pedal differential equation, and in pedal form the velocity expression is given by Vp equal to h. Okay, these two are the expression of force and the velocity. Now to find the velocity and force expression by using pedal differential equation, we first convert this equation or the polar equation to pedal equation. And how can transfer it polar to pedal? We first draw a tangent at that point. Okay, and let the perpendicular distance from the focus is given by s n, and this is the perpendicular and this is small p. Okay, and we know that the relation of p and r in differential calculus is p, this is equal to r sin phi. This is an important relation. And also another relation we use always, this is tan phi, this is equal to r d theta by di. These two are very important relation of differential calculus to make any polar equation to pedal equation. Now from this equation we first differentiate with respect to theta, and we get minus 2a by r square into dr d theta. This is equal to sin theta, right? And we put the value of dr d theta here, and we get tan phi. This is equal to r into, this is minus 2a by r square into sin theta, because d theta by dr, this is equal to minus 2a by r square into sin theta, and this is minus 2a by r into sin theta.